So basically the program works by calculating the phase difference for each individual transmitter, and then it uploads that data so that the waves generated by each transmitter is generated at different phase, therefore changing the directivity of the principal maxima. So that's the resolution bar, that's the frequency bar, that's the scroller bar to change the emitter size, that's the phase plane plot, which I have not yet implemented yet. So this is basically the drawing canvas, and you can see this is the distortion caused by the ultrasonic wave on a real image. It's pretty much like disturbance in water. So the canvas, and you can see the top left corner that shows the coordinates on the canvas. So you can just add emitters by clicking on the button. So you can see the disturbances or the ultrasonic waves propagating. Okay, so the clearing will refresh the canvas. So now if you observe there, you can see some points with relatively brighter pixels as compared to their neighboring pixels. So these are the points where the waves, due to the originating from the transmitters, are constructively interfering, so therefore therefore attaining maximum amplitude, whereas in contrast with the other neighboring pixels. So phase calculation, as soon as I press a point on the canvas, the algorithm calculates the phase delays for each individual transmitter, so that by changing their phases, or the rate at which they emit at which they are excited, we can change the direction of the principal maximum from the plane perpendicular to the arrangement of the transmitters. So as you can see, we're getting the constructive interference is changing its angle, and it's proceeding towards the point where it is clicked. So since these are nothing more than disturbances in space, or in the air pressure column, so by changing their orientation, we can scan an area pretty much like how a cathode ray tube scans the zinc sulfide screen or any other fluorescent screen in a television or any CRT monitor. So the positions basically indicate the position of the transmitters, and at position 3439 is the position where we clicked to obtain the phase calculation. And as you can see, you can delete the emitters, and yeah, the 122, the 8241 are all in milliseconds, and they give the phase delay for each transmitter. And as you can see, you can change the frequency, increase it, decrease it. So the algorithm basically for calculating the phase delay works by identifying the length by which each transmitter takes to reach the point of where we require constructive interference. That will be the length that generates the phase delay, and in order to counteract that delay, we'll advance the excitation of that particular transmitter by that particular time, so that it counteracts the loss in covering that extra distance. So using that, we are able to calculate the time, and then we just convert that into angle through 2 by ft thing, and then we feed that to the